we add a little piece to our limits today and talk about continuity and the three-part definition that we're going to use for continuous functions. Okay, so let me get this situated here. All right, here we go. So we have our graph, and you have some dots and some holes and some asymptotes and some all kinds of stuff going on with your graph. So we're going to fill in this chart with these 7 different things, talking about, is it defined? Okay, limit from the left, limit from the right. Then what is the actual limit, and is it continuous? Okay, so we'll take a second. We're going to fill this out. So now that we've filled out our table of values, we can take our 3 parts. In order for a function to be continuous, there must be a y value for every x value on that interval. Okay, the limit at that x value needs to be a real number, and the y value and the limit must be the same in order for the limit to, or for the function to be continuous. Okay, so this is the calculus definition of continuity, and when we use that, we're going to have to state all 3 of those things, okay, in order for you to do it 100% correct. So 3 more examples, and we have another graph to interpret. Okay, so pause the video, go ahead and look at these and do the 3 parts to say whether the function is continuous or not, and why. So for -8, the graph is not continuous because the y value is not the same as the limit. For -6, it is. Right down here, it is continuous because the y value does equal the limit. And then at -4, once again, it is not continuous. The limit does not exist, even though there is a y value. Okay, so we use the 3 parts of our definition of limits in order to say whether it's continuous or not. Okay, so how about we work on some more algebra then, so we can practice some of this stuff. So here are 2 piecewise defined functions, and we want to know if it's continuous at this value. Okay, so we're still going to use those same 3 parts. We're going to find what is f of -2. You're going to check the left of -2 limit and the right of -2 limit, and they all have to go to the same in order for it to be continuous. Okay, so we check f of -2, the limit to the left, the limit to the right, and then we make our analysis. Okay, so we do all 3 of our things. We find the y value using the correct piecewise function. You find the limits using the correct piecewise function and see if they are the same. So in this first example, they are not the same, so x is not continuous. And in our second example, they do come out to be the same thing. So at pi, this function is in fact continuous because the y value at pi is the same as the limit at pi. Okay, and now a little bit more algebra. They ask us here at the bottom, what are the values of m and k that will make this thing equal? Okay, well, that will make this thing continuous. So a little bit of sketching might help us see this. So here's your y-axis and here's your x-axis. We have a fence at -1, right? So we're separating this into 3 parts. Here is your less than -1 part. Right, we also have a part that goes to +3. And then you have everything larger than 3. So we're going to do 2 different types of graphs. To the left of -1, we are just going to graph the constant function +2. So we have a closed dot here at our fence, and +2 goes everything to the left exactly at +2, a horizontal line. And to the right, we're going to graph this horizontal line, -2, with a closed dot at +3, and then everything to the right as a y value of -2. So we have 2 horizontal lines that we are given to the left of -1 and to the right of +3. Okay? So what needs to happen, of course, is if our graph, right, and this is the graph that we're talking about, some mx plus k, some linear graph. If that function is going to be continuous, then the y value at our -1 needs to be the same for your two functions that are occurring at -1. Okay, the y values must be equal.
The y value is at 2 and mx plus k, right?
The y values everywhere the fence is. If your graph is going to be continuous, the y values on your blue fence at -1 have to be the same, as well as the y values at your red fence over here. So if we're going to have a continuous function, right, and it has to be linear, it says mk plus x, right, that's a linear function, right, not a quadratic or some type of a cubic or anything like that. This linear function, you need to make sure that the y value at +3 are the same, right, for your top and your bottom, and you need to make sure that your y value are the same wherever your two functions meet. Okay, if it's to be continuous, the y values have to be the same, right? Because the limit from the left has to equal the limit from the right, has to equal the y value at that point. Okay, so let's see what's going on. We want to find an m and a k so that the function is continuous everywhere. So in order for us to write the equation of our purple line, we need to know the slope and we need to know the y-intercept. Okay, so let's do a little bit more analysis. What are our coordinates? What are the coordinates on our blue line, our blue fence? The x is -1 and the y is +2. Okay, so that's our coordinate here, right? If we have two coordinates, you can find that point or the equation of a line. And the coordinates over here on our red side is
3,
+3 and -2. So with these coordinates, we can now find the slope by doing y minus y, 2 minus -2 over x minus x, -1 minus 3. Okay, and if we continue with this, 2 minus -2 equals +4 over -4, our graph has a slope of -1. 4 over -4 is a slope of -1. So that's our m value for our linear equation. We have a slope of -1. And what about the y-intercept? Where does this thing cross your y-axis? Looks like at +1. So our final analysis is if our function is going to be continuous, that middle equation has to be -x plus 1. Right, an m value of -1 and a k value of +1. But the key understanding is whenever your graphs meet, the y values have to be the same. Okay, the limit of a function is the y value, and the definition of that function at the x is the y value. So whenever you have these, you need to set your y things the same in order to find your missing letter. Okay, so limits and continuity.